and I'll show you why in just a minute, but this is the same idea that I have a loop, and my loop, let's see, okay, so I have a loop that's, oops, I have a loop that's circular like that, and it's perpendicular, so let me draw that better. Let me draw it like this. That's not any better. Alright, so this loop is facing this B field. Okay, so this is my B field right there. And alright, so now I have my E, MF, is equal to a negative d phi B, that's just dt. And remember, phi B is equal to B times A. So this is just, phi B just means magnetic flux. You could have electric flux, and then I'd call it phi E, phi sub E. All right, so now I'm only caring about the magnitude, so I'm going to say this is equal to a negative, or I don't care about that, the negative, so d phi B dt. And now what I want to know, what's changing here? And if I look, the area isn't changing. It's the magnetic field. The field reverses its direction, and its magnitude changes. So it's changing its direction. So here I have d dt of B times A. And so now, like I said, area isn't changing. This time it's the B. So I have A times dB dt. Okay, so let's plug in numbers here. Or let's plug in, our area is going to equal pi r squared dB dt. And so I'm going to have pi times, my r squared is 0.3 meters squared, times, now what is dB dt? dB dt, let's just write that for a second. dB dt, I like to think of it as B final minus B initial over the change in time, so the change in time. So that's what I'm going to write up here. So EMF is equal to, so pi r squared, and now I'm going to have my B final is 0.2 Tesla, and my B initial was 0.3. But the thing is that it changed direction. So if I think about, I have to go from 0.3 all the way down to 0, and then up to 0.2. So really I'm adding 0.3 Tesla plus 0.2 Tesla over 1.5 seconds. Now think about that. So imagine, like let's say, I'm going to just draw like a little meter like here. So let's say this is my 0 value, and this is my B value here. Let's say it was over here at 0.2 Tesla. And it has to go over here, it's going to change direction, it's going to go over here to 0.3 Tesla. Right? It has to go all the way through from 0.2 to 0.1. I'm sorry, if it started at 0.3, so I guess it went this way. So it has to go all the way from 0.3 to 0.2 to 0.1 to 0, and then to 0.2, if this was, say, negative. So I can see here that the change here is going to be 0.5. So my EMF then becomes, when I multiply this out, I end up, this equals 0.094, and here I have meter squared, and I have Tesla per second. And remember, so 0.094, and so Tesla is a volt second per meter squared, and now if I multiply it times meter squared per second, to get with those units, I end up with volts. And now look at this, if I move this over 3 places, I end up with millivolts. So epsilon is equal to 94, I'm sorry, EMF is equal to 94 millivolts.